So if you came in after I gave them out, there's some practice tests up here and some other sorted handouts from the last few days. I think I want to try to do, let's do, before we get into the next section, let's do another example of these system of three equations. Let's do one that's a little bit different. Now, you would think that if there were already some variables missing, it would be automatically kind of easier. And in a way it is. You just have to know how to work with it. Do you see what I'm saying? Like that second equation, the A's already dead. I didn't have to come kill it. I already died before I got there. It's nice. And then the last equation, C's dead. Died of natural causes. You guys with me? You see? So, who's got a suggestion on how to proceed? Because the normal way to do it is not going to exactly work, because I've already got some things that are dead.
Can't you just try to kill the B that's the same on all three? Or
Okay.
The one that's like...
No. Look at the second equation. What's already dead? A's already dead. So that is actually a valid way to do it. All right. Don't worry. Stay with me. Now, one reason I wouldn't necessarily want to do that is because solving this for B brings in fractions. You see that? Yeah, so if you solve the second one for B, what could you do with that? You could substitute in place of B, sure. You could substitute in place of B, and that would actually make two equations with A and C. It would work. So let me do something a little bit more directly related to what we've already done. And maybe this is what some of you guys are suggesting. What's another thing? Since A is already dead here, I just have to kill A one more time, right? Now, there are other ways to do any of these. But just to make it more closer to what we're used to already, how do I kill A one more time? That won't kill A. Yes, all right. I love it. Kelly's over there like, listen to me, Jeff. I know what to do. 1 and 3 are the only ones that have A's in them. That's the only way you got to kill them. If you add them, they just make 2 A's. Oh, shit. So I better do like 1 minus 3, right? So here's 1. A plus B plus C equals A. Now, negative 3 would be negative A plus 3B equals 3. Let me stop there for a second. You guys? I mean, it kind of makes sense. If a letter's already dead somewhere, I just have to kill it one more time. Because what do I normally have to do? Kill a letter twice. One was dead already. Just got to kill it again one more time. Kill me, baby. And what do you get? When you add these together, you get the A's cancel. Let me make sure everybody's understanding what's happening. This is one way to handle it if there are empty spaces already. That means that letter is already dead. So normally I have to kill a letter twice. Since one's already dead here, I just have to kill it one more time. And that's going to give me two equations with just B and C in it. So here they die. I get 4B plus C was 11. So that's my fourth equation. And now I can use my second equation. Yes? Say again? Add the, sorry? Okay, I really, let me write this one a little bit differently, okay? This is 1 plus negative 3. I'm always going to add the equations together. So what do I always want to make sure is true about the variable I'm trying to kill? I want them to be the same number of different signs. So they'll cancel, right? So what I'm really doing is I'm taking 1, I'm leaving 1 alone, but then I'm multiplying 3 by negative so that the A's will cancel. Is that cool? Take the third one, change all the signs, multiply it by negative 1. That becomes negative A plus 3B, positive 3. Okay. Now the A's will cancel when I combine them. So nothing really new. It's not really new. It's like the first step was done for you. Now I could have also killed C between these two, right? Because I already have C dead here. I could have killed C, but you just got to pick a letter like always. Whatever letter you want to kill. So the process isn't really different. It's just that 1A is already dead. So I just got to kill A again. What's the only way to kill A? Well, with the equations that actually have A in them. So how do I kill the A's? Well, right now they won't die if I add them. So I have to multiply one of those by a negative, so they will die. It's the same thing we were doing before. Jeff, stop doing that. I'm sorry. I'm like cheering you on. Come on. So now I have these two equations down here, and I can just work with them like normal. What can I do with the first one? See how the C's already have opposite signs? Yeah, if I multiply this by 2, I'll get 8B, 2C, 22. What I like, it looks like Jeff made this a little bit more gross than I wanted to. Oh well, these things happen. So you get what? Yeah, good job, Jeff. That's 9B equals 20. So B equals 20 over 9. Oh my God. All right, let's not go further about it. Jeff tried to make one in his head, and obviously I missed something. I didn't want to bring in fractions like that too quickly. But you guys understand the idea of a problem where there are already holes. One way to take care of it is to go, oh, thank God, they did my first step for me. Let me just kill that same letter again. Because we normally have to kill it twice. Somebody killed one of them for us. All right, we can sleep a little better tonight. Only had to kill one thing today, not two. All right. Because again, what did we do before? On this first problem, we killed X twice. Why? Because they're all alive. I had to kill X twice because they're all alive. Here, I only have to kill A once because one of them is dead. So it's not a different procedure. It's the same procedure, but somebody already did some of the work for me. Okay. Now, to get into the next idea. notice, let me point out a couple things, because we're about to get into an idea that's more general than just this one section. There's a lot of shit we deal with here that we shouldn't have to. Everything in the first column, you guys understand what I mean by that? Like, here's the first column. They're all X's, right? And of course that makes sense. I would kind of rearrange things if they weren't. I would all my X's together. You with me? And the next column is all Y's, Z's, numbers. I like it. So of course if anybody was out of order, I would rearrange it, wouldn't I? And then what tells me what to do? What really tells me what to do? If I want to kill the X's, what tells me what to do next? Like, why do I know I can add 1 and 3 together and that's going to accomplish something? The coefficients, right? Once I get all the X's lined up, the X variables themselves don't mean shit. I'm just trying to make the coefficients cancel each other out because that means that that variable goes away. So I can develop a method that allows me to not have to rewrite the variables over and over and over again because they don't matter. Once I get them lined up, who cares? Like if I wanted to kill the Z, how would I do it? What tells me what to do? What could I do to kill the Z? Kill a Z between two of those. Multiply top by -2. I love it. And add it to the last one, right? What told you to do that? The Z told you to? No, the freaking coefficients told you how to kill them, right? Make the coefficients same number, opposite signs. So math people, we don't like to write a lot, obviously. Me personally, because I can't too well. But we just don't like to write a lot. We like to make a procedure where I don't have to keep writing shit if I really don't need to. So what we're about to get into is called matrices. Matrix, right? It's got nothing to do with Mr. Anderson or anything, but it's a way of focusing our attention on what's important. And something that's not going to really affect us, I'm going to show you how to do them in the calculator, but the calculator can't handle freaking variables, but it can handle a bunch of freaking numbers. So I could put a matrix in a calculator, it's going to spit out the answer to me. That's awesome. But that ain't your work. Your work ain't, I push this button and this happened. No. But it's a nice way to check your work. Shit. So here's how this kind of gets developed. I want to change this into a matrix. I just focus on the coefficients. I make sure everything's lined up. X's, Y's, Z's, numbers on the other side, right? And then it doesn't matter. The variables don't matter. So what's going to go in there for this first column is just going to be 1, 2, -1. And that first column is the X column. How do I know that? Because I put the freaking X's there. So the first level of this is, do you understand how to go from a system of equations to a matrix? And then we got to talk about, okay, once we got a matrix, what the hell do we do with that shit? Okay. There is no square root. What about the next column? What's it going to look like? 1, -1, 2. Does everybody see that? All I'm doing is writing the coefficients. And why am I doing that? Because I should have a way to do it. They're the only things that matter once I got all the variables lined up. Why do I have to keep writing X over and over and over again? It's stupid. If I got a 2 and a -2 in front of it, I know they're going to cancel. That's all that matters is the coefficients. So the next column, 1, 3, 2. And then I draw a line here, kind of like to go with the equals. So the line separates variables from numbers. What's going to go here? 6, 9, 9. So that system of equations looks like this when I put it into a matrix. Now that step right there by itself is not that difficult to see. You're like, all right, just put all the numbers in front all by themselves, Jeff. That's a good job, Jeff. Now, the next level is, how the hell do I deal with this? And does it make it actually any easier to do this? It's a big question. So right now, on the heels of this, I want you guys, let's see. Let me come back to that. Write this as a matrix. this test, yeah. That's the only new thing. All right. Let's see if we can do this by equation by equation. Let's see, what's the first row going to be? 2, -1, 4, -3. Now what's kind of evil on the next line here? Yeah, so let me move that x over. See, that's what you do. You make sure that all your x's line up so you don't put the coefficient in the wrong place. So what goes here? 1, no y's, -4 z's, and the 5. 6, -1, 2, 10. Okay. So just converting a system of equations to a matrix by itself should not be that big of a deal. Right now you're all like, yeah, I could do that, but what the shit good does that do? All right, give me a second. I got to explain. All right. Now before I go back to that previous page, down here, can you guys go backwards? Take a minute and see if you can write that as a system of equations. Just go reverse. I put in the line here just to make it clear.
That's the equals?
Yep. That's why I always include that line when it's a system of equations. Make it real clear. Otherwise it's evil. Both of them. Yeah. Maybe you'll see why that second one is like in a beautiful form. Yes. Yes. It's basically you can pick whatever letters you want to, since it's not specified. Normally you use X, Y, Z, but you can use A, B, C, whatever. So this matrix, what do you guys get for the system? That's the first row. I like it. Now, what else would be acceptable? A minus 4b equals 10, b equals 2. That's also that's the same thing. They didn't tell me what letters were used, so I can use whatever letters I want to. To be very honest, there's nothing special about X and Y. You guys need to know that. I know algebra makes it seem like there is, but there ain't. They just were picked. They just were chosen. What about this guy? Wow, this guy is beautiful. Good cry. What's the first row?
X equals -1. Y equals 7. Z equals 2.
So it seems like if I can figure out how to make a matrix that starts off like this, if I can do stuff to make it look like this, I can just read the answers off. That last column is just all the answers. You guys see that? If I can make this part look like this part, then I can just read off the answers at the end. X is that, Y is that, Z is that, bam, bam, bam. Oh, shit. Now, I still haven't told you how this is going to happen, but I'm trying to build up to that. I want it to make sense why that is my goal. When I set up a matrix, that's my goal. Why? Because then I can read the damn answers off. A 0 in a matrix means that I killed that variable. And isn't that what we've been doing? Trying to kill the variable because there's too many of them? Kill. Out. There's no shit. Cockroach variables. You never know. So all right, to get a little bit technical on you, this is what's called reduced row echelon form. Oh my God. Just go.
Upper echelon?
Are you thinking about upper echelon? I like it. So in English, the word echelon means sort of like tiers. So you'd be the upper echelon. Ooh. Right, the gold medal winners. And then the next echelon down. All right. Okay, so reduced row echelon form means something like 1, 0, 0, 0, 1, 0, 0, 0, 1 with numbers here. Now, how many equations does this represent?
3.
And how many unknowns? 3. So if I had a 2 by 2, 2 equations, 2 unknowns. My goal would be this. These are numbers, right? Number signs. Number. That's my goal, right? Why is that my goal? Because then I can just read the damn answers off. Now, I don't really like doing this because that's sort of like undone. So here's an example of something in row echelon form. 1, 2, 3, 7, 0, 1, -1, 4, 0, 0, 1, 2. Do you see why I don't like that as much? Can you just read the answers off? No, because these aren't done yet, right? What does that first equation say? See, that's not solved yet. This is much better. X equals that number, I'm done. Okay. Again, I still haven't told you how to do this shit yet, but I'm trying to build. Okay. All right. Now, let me take a step back, because poor little matrices, this is not their only purpose. They exist on their own in the wild. You can have all different kinds of matrices. We have dimensions. We talk about dimensions. How many rows are in this first one? Careful. Where are the rows? Here are the rows. Here are the columns. Think about Greek columns. What do they look like? Like this. So those are columns. These are rows. So it's 3 rows by 4 columns. That's a 3 by 4 matrix. Just the previous page. The previous page. I skipped this page earlier. We're good? Okay. Sorry. Still, I forgot to put page numbers on this for them. What about this next one? What's the dimensions of this next one? 2 by 2. What about this dude? Careful, it's rows by columns always. Row by column. 4 by 2. 4 rows, 2 columns. And what about this guy? 1 by 1. I like it. So it kind of makes sense. How would you describe this number right there? It's in the what row? Second row. Second column, right? So this one I would say that's in position A22. Second row, second column. What about like this one? What's that? What row? Third row. Third column. Why do I keep picking the same number, Jeff? That's really not useful, Jeff. All right, sorry. What about this one? Where's that one? Oh, shit and a half, Jeff. It's not that hard. Let's try that one there. What about that 5? Where's it at? First row, 4th column. I like that you're right there with me. So laugh at me. I appreciate that. So look. First row, first column, second row, first column, third row, first column. That's a quick way to identify a single piece of a matrix. It's just like if you go into a very well lined up neighborhood, you can say I live in the 3rd Street and the 4th Street up. And it's the same kind of idea. How do I find something inside of this grid? So AIJ is located in the ith row and the jth column. You gotta love that. Ith. It's easier to say than iond. Iond. So we say ith and jth.
Is a row horizontal and the column vertical?
Yeah. Just remember, what about Greek columns? What do they look like?
Straight up.
Yeah, like that. So that's the column, row. Yeah. Okay. All right. enough of that. I'm not going to focus too much on this, but you have to at least know how to identify matrices by dimensions. Okay. So let's start to step into how do I use a matrix to solve an equation, a system of equations. So somebody ask you this. Guys, what are the rows? Every row represents what in actuality? Every row represents what? An equation. I had to process what you said. Guys, what are you allowed to do with two equations? You can add them. Yeah, you can switch them around, right? They don't have to be in any order, really. What can you do with a single equation? You can multiply it by something. You can divide it by something. So what are you allowed to do to rows? All the same shit we just said, because what is a row? Freaking equation. So I can add two rows together. I can multiply a row by something. Anything I could do with equations, I can do with rows. Why? Because rows are equations. I can see in your face, you're like, oh, I love that this is here, and I get to do this. Sorry. How do you capture facetiousness in sign language? I don't know. All right, so look. You guys do what they say. Can you guys handle this? What is this asking you to do? Switch row 1 and row 3. So do it.
So it's the same to put row 1 on the bottom and row 3 on the top?
Isn't that crazy? And let me ask you, as you're doing that, we're starting to develop the process. You remember what I said earlier? That this is our goal when I have 3 equations, 3 unknowns, right? This is our goal. Do you guys see why switching those rows makes sense? I really want to get you guys thinking the right way. What do I want to have up here? A 1, right? I want a 1 right there, don't I? You guys with me? This is my goal. Why is this my goal? Why is this my goal? Because I can just read the damn answers off, right? So it makes sense. I want to be able to get here. So why are they asking me to switch row 1 and row 3? Because that would make a 1 go where it's supposed to be. Right? So if I switch them, I just get 1, 3, 2, -8, and row 1 goes down here. I'm going to draw the line in. They don't seem to like the line. That line keeps me straight. So all I did was switch the 2 rows, right? Why was that a decent thing to do? Because it got me 1 step closer to my goal. Okay. All right, now do what they say for number 2. See if you can do that. What is this? If you read this, what does this kind of say? It says, cut R2 in thirds and then put the answer back into R2. R2. No? Really? That's not. Just, oh, you're like, I got it. I like it. It was fun.
Do we keep the same equation from number 1, or do we just use a like kind of
Just work with this right here.
Okay.
Yeah. See, everything else stays the same. So what happens when you divide this row by 3? 2. Now that doesn't get me closer to my goal, but it does make the number smaller. So of course, anytime I can divide a row by something, I will. So all my numbers get smaller. Okay. Yes, ma'am. We're gonna talk about the process of how to get to that goal. And in order to get to the goal, I'm gonna have to do all these things. Possibly, right? Now try to do the last one. Or, pretend like you are. Whatever. I'm going to let you do it however you see how to do it, and I'm going to show you how I do it. You can pick whatever way you want to do it.
So do we multiply R3 first?
Yep. That's what it says, right? Take negative 6 times row 3. And then add that to row 2. Do you see what that's going to accomplish? Oh, you guys love it. So guys, here's how I do this. I'm not going to rewrite the row. Why are they multiplying row 3 by negative 6? Because when I add it here, what am I going to get here? And isn't that part of my goal? Is to get a 0 here, right? What's my goal again? My goal is 1 0 0 0 1 0 0 0 0 with numbers down here, right? Reduced row echelon form. Right. So guys, here's how I do this. You don't have to do it the same way. You can do it different ways, but this is the way to do it quickly. Do I need to leave row 3 as multiplied by negative 6? No, I want to leave it the way it is. It's better the way it is. So I'm just going to put next to it what negative 6 times each one of these is. Oops, pause it for you. Right? Negative 6 times 1, negative 6 times 3, negative 6 times 2, negative 6 times negative 8. And then I'm going to add it to row 2. Negative 6 plus 6 is?
0.
Negative 18 plus 12? Negative 6, I like it. Negative 12 minus 3? 48 plus 3? And then the other two rows stay the same. Now, oh shit, you guys can tell me you can't see what I'm doing. You're all like, well, I guess we just won't see. So negative 6 plus 6 is 0. Negative 18 plus 12 is negative 6. Negative 12 minus 3 is negative 15. 48 plus 3 is 51. All I did was add a series of numbers together. It's amazing, Jack. Now why is that this matrix better than that matrix? Because it's closer to my goal. Okay, so this just gives you an idea of the things you're allowed to do. What are you allowed to do? You're allowed to switch rows. You're allowed to add rows. You're allowed to multiply rows by some number. Why are you allowed to do those things? Because that's what we can do with equations. That's what we did with equations in the last section, right? We multiplied so that the coefficients would cancel. So in the matrix, what do you get when you've killed a variable? You get a 0. So really what you're trying to do is get a bunch of zeros so that you've killed those variables. So you can see what the other variables are. Okay, so let's do a problem. I want to do a problem. Let's do a small problem, and we'll do it both ways. Just to show you what it looks like in both ways. So let's see. Let's take a nice little tiny system of equations. Let's see. X minus 5y. Oh, I gotta make it work, don't I? It was negative 2. Negative 2x plus y. Oh shit, what was it, John? Oh yeah. There. Let's see if this is better than what I did earlier. Yes, okay. It should be fine. So what I'm going to do is right next to this, I'm going to put the matrix. And every time we do something to this system of equations, I'm going to do the same thing in the matrix. Aw. Okay. So what would the matrix look like? Okay. Now, I want to say something as we get into this, because students, number one, I can feel that most of you already are like, do we really have to do this? We are learning something new. It actually does make it easier, but as you learn it, it will first be harder than it was in the last section, of course. It only makes sense. Also, on a system of two variables, two equations, matrices actually make it a little bit longer, to be honest. But 3 by 3, well, what do I mean when I say that? I mean 3 equations with 3 unknowns. It's about the same level. But then if I had 4 equations with 4 unknowns, screw the first way. Shit. The matrix would be so much quicker. So just keep in mind that you are learning how matrix works. Don't lose faith and go, well, this is bullshit. I could do it quicker the other way. Of course you could, because you know the other way better. So you got to learn the matrix way fully first, and then you can see how quick it is. That's my hope. All right. So what would be the first step? Doing this by hand, not by matrix. What would be the first step? Multiply 1 by 2. All right, so twice 1 plus 2, right? So what's twice 1? And what's 2? Now we'd add those together, right? Is that cool? I mean, that's... So you get...
-9y equals -9.
Alright, before I do any further, now watch. Here's what it looks like in the matrix. Alright? So what I normally do is I put a little arrow and then I put, just like they did on the previous page, what would be the equivalent thing we did? And notice, ones kick ass because they become any number I need them to become easily. Can I make 3 become 2 easy? No. I gotta multiply by 2 over 3 and then, But can I make 1 become 2 easy? Shit, yes. That's why ones are really nice, because they make making zeros easy. And what's my purpose when I have a matrix? I want to make zeros. Because what does that correspond to? Killing variables. So really what a matrix does is it kind of refocuses our attention, and then we just keep doing the same thing. It's beautiful. It just kind of makes, find a 1, make zeros. Find a 1, make zeros. Find a 1, make zeros. It doesn't matter how big the freaking matrix is. I just keep doing that same thing. If I make 4 equations with 4 unknowns, holy shit. Okay, let me pick a letter to kill. No, oh my God, I got to do it 3 times. It's just disgusting. It's just a mess. So here, what would the equivalent thing look like here? I would take, here's row 1. What did we do to row 1? We doubled it. So I would take twice row 1, add it to row 2. And now, remind me, let me see. Again, we're learning this, so please, dear God, give it a chance. What's the goal on this one? What do I want to make this look like? 1, 0, 0, 1, number, because then I know x equals that and y equals that, right? X equals that, y equals that. So when I add these together, where do I want to put the answer? Which row? You get to pick which row you want to put the answer. Well, which row do I want to put the answer in? What's going to happen when I do twice this plus this? I'm going to get a, and where do I want the 0? Here. So I'm going to put the answer in row 2. Now let me say another thing too. All right. First few times we do these, I'm going to do like every step explicitly. And as we do a few more, I'm going to show you some shortcuts. Shortcuts, and you can do several things at once. Because if you have to rewrite the matrix over and over and over, it's just going to be like, what the hell's the purpose of this shit? It's supposed to make it quicker. So, I want you to know that. So let's see, what do we get? So how would I do this? I'm not going to rewrite the whole matrix and put 2, -10, -4. I'm just going to put it up here temporarily. 2, -10, -4. See how that corresponds to this? Right? Not a big, amazing thing, because it's the same thing. Maybe. So now I take 2 minus 2 is 0. Negative 10 plus 1 is negative 9. Negative 4 plus negative 5 is negative 9. And the first row stays the same. So especially in the early going, I urge you to only change one thing at a time. But later, when we get a little better, we can do a couple things at a time and make it go a little quicker. Now, doesn't that correspond to where we are here? So here, what would I do? Divide by negative 9. And here, what would I do? Same thing. I would take row 2 and divide by negative 9. Put the answer back into row 2. 0, 1, 1. Bam! What's that last row say? Y equals 1. So really, one thing, the other thing that the matrix does for me is as I make better equations, it keeps track of them for me. I don't have to kind of like keep track of it myself. It's all, everything's right here. It has the old equations with the better equations, and I keep making them better and better and better. So now, what isn't right? There's my goal for the matrix. What isn't right here? The 5. The negative 5 should be gone. But do you see how this row is so beautiful? It's got a 0. It's not going to screw with that 1. It's not going to change it. Do you guys see that? So what I always say is you get a column finished and then you move to the next column so you don't mess with anything. You don't lose any zeros or mess up any ones. So now how do I kill this negative 5? What can I do to this row 2? How do I kill this? What do I make this become so it kills this? I like it. So if I took 5 row 2 and added it to row 1, where am I going to put the answer? Where do I want the 0 to show up? Beautiful. And again, I know right now, y'all, I know you're doing exactly what I said earlier. You're like, oh my God, I would have been done over here. Shit. What the shit? To be really honest, I would not use a matrix on a 2 equation, 2 unknown. I wouldn't. But it's really good to learn how they work on them because they're easy, right? So all we're doing right now is learning how these things work. So what do I get? So I put 5 row 2. So what's 5 times 0?
0.
I always get somebody to say it's 5. It's crazy. 5 times 1 is 5. 5 times 1 is 5. That's crazy. If I add them together, 0 plus 1 is 1. 5 minus 5 is 0. 5 minus 2 is 3. And the second row stays the same. So now what's the answer? 3-1. I can just read it. Make a 1, Jeff. There you go, buddy. I can just read it off at the end. That's the answers. Get the other sheet down. Just to remind you guys, as we get deeper into this, shoot. Oh, there we go. On the other side of this sheet, I have an example of 3 equations, 3 unknowns, with all the steps. Please try to have a little bit of faith. All right, I'll see some of you guys in a few minutes in the lab. Don't forget, next week are quizzes in the lab. Monday, Tuesday.
Did you get my email? I sent an email.
What'd you say?
I said I was in the hospital.
Did you ask for anything?
On Tuesday. I was just, I think
Just telling me?
I just
Yeah, okay.
asked what
Okay.
happened. Did we get that?
This one I gave out a while back. This is the one.
Okay.
You can have one if you need one.
Yeah, I don't have it yet.
And the practice test you just gave out today. Okay.
Cool. Thank you.
Sure. The lab, the group worksheet?
Did you pass out something in lab?
Yes.
Yes.
We worked on a group worksheet. Where,
There's a matrices one.
yeah, here we go.
The practice test?
There it is. Let's see, where do I have an extra copy? Do I have an extra copy? I should. Hold on. Here we go. Yeah, this is the one we did today, or in yesterday, in lab.
Okay.